Good, good. How about you? Anybody, excuse me, anybody here that wasn't here Monday? You need a syllabus? It's online too if you forget or lose it. Sorry, Matt. Cough in your headphones. Any questions about logistics stuff? If anybody, I hope, went and read that. Or things that were confusing from Monday or you thought of?
So I did the assignment online. And so once you submit it, once it's due, we'll just take it off. So I went and clicked on it, it doesn't go away once you submit it.
Correct.
Is that okay?
Yeah. Because say you, on one, you can have 3 submissions, you know, you can tell. If you click and it doesn't do anything, you're done. But sometimes it'll allow you to give another answer. Example, I intend to, see how it goes with multiple choice. Say there's 3 choices. You submit one. It'll tell you right then, once you submit that question or the whole assignment, there'll be like a red X or a green check. Green good, X bad. You got it right or not. And so if there's another submission, it'll allow you to select a different one. Because I would prefer that while you're thinking about it, okay, well, I think it's this then. You'll get less points, but it's better than a 0. And with written ones, I'm trying to figure out how to do it. I haven't yet. Where you have to write something. Say you decide the next day before it's due that, I want to say it this way instead or add that or whatever. You could, in theory, go back a few times and reword it. Once it's due, yeah, you'll get to see the solutions then. I saw.
Okay. If you submit each problem individually, do you still have to submit the entire assignment?
Probably not.
Probably not.
I don't see why you would. Hit it. Yeah. You're doing them all individually. It's usually as you work them down, like when I was practicing, I'm like, okay, I answered number 1. I'm not submitting it yet because I might change my mind. I go to 2. And you see I saw something that pops up that says, if you hit submit on number 2, it'll submit 1 as well. So as I kind of worked my way down, so I just kind of saved my progress periodically. And then once I really felt like, yeah, I'm good, submit. I encourage it that way. I just think that way you won't be mad at yourself for going, oh, dang it. I learned something about this one, but I already submitted it. You might as well just save your progress and wait a moment.
If you using scientific notation and the pen is raised to a positive power, you have to
put the plus?
You have to put the plus sign?
In that scientific notation, no, you do not. There was a link. The minus you will, yes. For scientific notation. If you noticed in there too, there was a link to instructions of scientific notation and to free your mind now. I'm not going to use scientific notation or require it in an answer. That assignment I gave you, the content of those questions, they were generic so we can use them across multiple classes. If you didn't understand any of that or know how to do it, that's okay. The whole point of that assignment was to can you get into WebAssign? Can you see this assignment? Do you see the types of things I can ask or the different ways to do it? So even if you got the wrong answer, I don't care. I'm looking to see if you did it. That's what you'll get credit for on that one. So scientific notation, I might write it on the board in shorthand, but I won't. I have no intent of requiring that in an answer at this point. You purchase it right there. You know how I gave you an option? Find it in your book, purchase or continue free trial. Once you're free, yeah, you can do it any time, but before your free trial's up or after, purchase it online right there. Follow the links. So it is not hiding in your book somewhere. I'm thinking it was $25. We're going to use that all semester as a ways to submit assignments. if I was a student, I like it, and that's one big reason I'm using it is because you get immediate feedback. You don't have to wait for me to return the solution. As soon as it's due, you see the solutions. It's a neat form. The grader doesn't have to decipher your handwriting. That's a big reason why I'm doing it. I saw a hand over here.
Yeah, so it doesn't ever tell you it's confirmed when it's submitted. So I did it and had the green check marks and stuff, and that's it, and I didn't have a score. So does that
Yeah, it doesn't. It won't score you yet until it's due. Yeah,
so then
you'll know whether or not you got that individual answer right. But say essays, it won't tell you that if you're right or not. But, yeah. But the score will show up after it's due. Yeah. Yeah. And you'll be able to go back to those anytime this semester. They'll be right there for you. You don't have to lose it. If you didn't realize, you can print those out too. You don't have to do them online. There's a button for print. You can work on them. When you're ready, go back, enter them. Same when you get to the solutions, if you prefer, Anybody read the superhero paper assignment? Raise your hand if you did not. Okay, I'll give you a chance before we go into that more. Read it and we'll just see what you guys think. I mean, in my mind, everything's there, but I could be missing something you're thinking about. So, and again, you can turn that in anytime before that due date, and you have like 3 months. It's like it's into April, so gives me time to grade it before semester's over. I hope you'll enjoy that. Probably most of you won't start because we're all lazy, but also you don't really know some of the physics concepts yet, so it might be more helpful to know some to get an idea to what to write about, but that doesn't mean you can't go look or ask me ahead of time or start thinking of, ooh, that'd be a good superhero. And if we're not covering it in this semester, for example, I don't anticipate us discussing electricity and magnetism. Doesn't mean you can't use that for the superpower. And I'll help you if you would like to do that but can't find info or don't understand it. Yes?
So, the superpower that we decide, it doesn't have to actually cover anything that we're going,
No, I won't, we don't have time to cover every physics topic. So if your superhero power wants to be a topic I won't be discussing, or it might not even be in the book. That's okay, as long as it's physics. All right. I know some of you, I assume, because I wasn't as quick as I thought, with the clickers. We'll try them out today, see how it works. I'm not holding you to something yet. We'll practice. I intend to get to those. We'll see what channel I'm on, and if the old ones still work, which we got confirmation they said they should. And the activating, though, the link is in WebCT. I guess technically it's online Blackboard learning, not Canvas, because I'm just using the old one. Online Blackboard learning. You go there, you can see your classes. You go to this class, and the only thing there is a link that says register your clicker. There's a device ID number on the back. You enter that twice, and that activates it so I can see it and record the fact that you're here using it. That's what we'll try out today. See how that works. Okay. Chapter 1, about science. What the hey? I know it's the beginning, you're overloaded, you might not even have your book yet. Who's read it? Oh, I love you. Because this is the last lecture I'll be on it. These will be into chapter 2. I'm flexible with the gauge here of the way the classes are going to go, but this is my intent, to give you an idea, because no sense leaving you in the dark if I know what I'm doing. My intent is every 4 lectures, and then there'll be a homework assignment due. So like Monday, Wednesday, Friday. Next Monday's a holiday, by the way. So the following next week's Wednesday, and then your homework will be due after after that, later in the day. And then, another lecture, and homework would be due. Then we'll review and have a test, wherever we're at. But to give you an idea, so about every week and a half is my intent to have homework. No, I have not posted your homework, about this stuff yet, because I have not figured out how to split the points up in the essay question yet, and the guy hasn't gotten back to me. If you do not have enough time, don't worry, I'll give you enough time and extend that due date. Don't worry, I won't leave you hanging. That's not fair. But it hasn't been posted yet, so don't worry. The only thing was that practice WebAssign homework. Okay. The chapter starts out about scientific measurements. Measurements are very important to scientists. Units are big. You guys remember the NASA fiasco? Anybody? It's like putting a square peg into a round hole or vice versa. I don't even remember the details anymore. Do you? I saw your hand swing up. Something about two different teams. People were working on something, and one team used one units and the other used another units, which shouldn't be a problem, but they didn't really check the units, and so they just kind of used the values, and it didn't work out and caused a problem, just because they crossed units and didn't pay attention to units. It's very important. So if you ever catch me just saying, "Oh, it's 50," 50 what? Because it doesn't mean anything without units. Science is very factual and to the point. It's meant to be not subjective. An example, what was it? I had one. I thought of it last night. I wanted to share it. It'll come to me. Yes. I was curious how much the department charged me for liquid nitrogen, so I was calling up, and she didn't know. She was looking on the purchase order, and it was something like $6.42 is what she told me. Yeah, wow, we get that big white tank out there hiding for $6. Yeah, how much? There's no units. I need a measurement here. Okay, $6.42 per container. Do you happen to know what that container is? No. Oh, wait, I found something. $6.42 per container, and the container has, I don't remember, 200 units. This went on for like 5 minutes. Unit? Well, what's a unit? That ended up being, a unit's 100 CFs. What's CF? It didn't help. I ended up calling the company. They haven't gotten back to me. But I now know that I get charged 60 cents a liter. 60 cents per liter. That's pretty cheap for me, so that's good. I'm happy. Point is, measurements are important. And whenever you do something, you need to include it. And scientists have an international unit system. And us in the United States are a little behind the times. And so you have to watch sometimes when we talk to other people. They know what we're talking about. They don't relate to pounds quite as much as we do. They like newtons, units of force. Or we like miles per hour, and everybody else likes kilometers per second or hour. So you just got to watch it. He gives some great examples, which I think are very useful, of how they came using some measurements. I'm going to skip to mathematics. We don't avoid mathematics in this class. We just don't do it as much as the other physics classes. There will be problems. There are equations. Mathematics, to me and the author, is the language of science. They're guides to thinking. In my mind, I love them because they're shortcuts. It's shorthand notation to remember something, so you don't have to write out 2 long sentences. You can sum it up in 3 letters, as long as you know what it was in the first place. It's shorthand. And you can look at them and conceptually, without even putting numbers in, realize, let's see, so if mass is bigger, if that value is bigger, then that means this is going to be bigger. If time doubles, but time is squared, in the equation it's t squared. Well, if you double the time, you have to square that doubling. So something could increase 4 times as much just if you double it. You get the idea anyway. So I'm not going to avoid putting equations on the board and asking you to try to use them, but they're not going to be scary, I hope. All right, my daughter just turned in her science fair project yesterday. She entitled it The Puke Process. She's in 5th grade. She was all excited. We got an IV bag, filled it full of green fluid for the bile in the liver. And I attached it to a tube, and she could squeeze it as the muscles contract, and it was great. The shot out and puked up. She was all excited. In my mind, it wasn't the best science fair project, but she was proud and she learned something. How many of you guys have done a science fair project before? At least half, it looks like. What did they all probably require you to do? A certain method. The scientific method. Any of you remember any of the steps? Just shout them out. Hypothesis. Stop. What's a hypothesis?
Hypothesis is an educated guess based on observations.
Oh, you said that beautifully. Say it louder.
Hypothesis is an educated guess based on observations.
Yeah, an educated guess. Does that mean you know the answer? No. No. Is it okay if you're wrong?
Yes.
Absolutely. Great. So we make hypotheses. And I'm going to ask you to make lots of predictions in this class. You can think of those as hypotheses. I don't expect you to know the right answer. That's what I'm here for. But I want you to commit, because if you don't have an idea what's going on, when you find out what's going on, you're less likely to remember it or care. So a hypothesis. Good. What else? Say again? Recognize a problem, yeah. You're interested in some topic usually, but what about it? Yeah, you need to question. My daughter started because she's thrown up. She doesn't like it, like most of us. And she wanted to know, well, what's going on? What happens inside my body when I throw up? Why do I throw up? That was her question, her purpose. So she made a hypothesis, and she was wrong. Then what? Or what else? Yeah, perform an experiment. So she had to devise something she could do to help learn if her hypothesis was right. She made a model and played with it. Good? Are we done after that? Conclusion. Yeah, that's basically, it should be, in my mind, the right answer in case your hypothesis was wrong. The real reason it worked. Hopefully you learned that through your experiment, or at least part of it. Anything else? Generate a hypothesis. That's right. You got to predict in the first place. Yeah, there's a lot of scientists. I learned more when I fail, or the experiment didn't work, or it led me to something. Oh, okay, that gains. Well, that means I could redo the whole thing. Essentially, like starting doing something different, a new experiment, slightly different, adjusted hypothesis, and I'll keep gaining more and more and more each time. Yeah. In there too is data and results, which is how you get your conclusion. There has to be a way to test. That's a key point in science. Experimentation. You devise the experiment, you got to do it. You got to be able to test it somehow and get data and results so you can have a conclusion that's valid and that everybody will believe, because it's not subjective. But if you can't test it, then it's not a scientific hypothesis. And that's important to scientists. I said the first class, there's lots of things, people have questions or things they want to find an answer to, but you can't do it through science because you can't test it or prove that it's wrong. You have to be able to prove that it's wrong. So a lot of people list the scientific method. Those are the main steps. There's no one dead set method. But that's the gist. More of that philosophy and attitude of science is more important. That you got to be precise, follow those, some kind of organization. And I wrote it here. The success of science rests more on an attitude common to scientists than on the method. If you're not willing to be inquisitive and start looking, and more importantly to me is integrity and honesty, that you're not biasing your results. And if your results say you were wrong, admit it. Test again, lots of time. But if it keeps coming out that way, fess up. Don't cheat, because you'll be found out anyway. Because if somebody else tries to repeat the experiment and says, no, I don't think so, then you're discredited and they don't believe you as a scientist anymore. So a willingness to admit error is, I think, in my mind, more important. I'll tell you when I'm wrong. If you find that I'm wrong, call me on it. That doesn't bother me one bit. It does many scientists, but that's their problem. Okay, and the science, fact. There are many definitions in here. I'm going to read them. I thought about writing them down here, but I got them right out of the glossary. You guys can have them. You don't have to write it down. A fact. You guys guess first. In science, what's a fact?
Something that's universally accepted as true.
I like how you worded that. Does that mean it's necessarily true? Yeah, but we all think it is at this point, and universally everybody seems to agree on it.
1,500 years ago it was a fact that the Earth was flat.
Perfect example. So that was a fact at that point, and they built things around that. Once they found out it wasn't, they threw it out the window and went with the new stuff. Good for them. Good for us. Yes. The book says, a close agreement by competent observers, I like how he threw that in, of a series of observations of the same phenomena. So we generally notice that, hey, this keeps working. We're going to call that a fact. How about a law or a principle? I like that. Yeah. It's been tested over and over again. You can think of your hypotheses. You take one, and if you tested it, and you verified it, and again, and other people, over time it's like, gee, that's probably right. For now, we're going to call that a law and a principle, and it's going to be a guide to our thinking until we know otherwise. Yes, it could be wrong. And if somebody ever does a test that proves it wrong, and we can repeat that, then we'll start revisiting it and we'll change it to adjust reality. Scientific theory. And I say scientific because the scientific theory is a little different than we normally think in the layman's world of theory. What's a scientific theory? It's more ambiguous in my mind to general folk. Yeah?
It's an idea that's been tested a few times, but it hasn't been accepted as law.
Yeah, I like that. And again, it might not be right. But in a scientific, layman's, that's just a theory. Somebody thinks that. It's almost like a scientific hypothesis. That's somebody's educated guess. Based on a bunch of stuff, they think this is going to happen. That's what we usually think of as a theory. A scientific theory, no, it's a kind of a conglomeration of all these hypotheses put together that have been verified over and over again. And we base it off of laws and principles. And so it's not a law yet because maybe we don't think we've tested it enough. So we still call it a theory. But it sure seems to hold true as far as anybody knows thus far.
And can a theory involve more than one?
Yeah, it's kind of more general than just a law, one law. We're going to do Newton's laws. He has a first law, second law, third law. You could think of Newton's laws of motion as kind of a scientific theory, encompassing all of it. That's how I think of a theory. Good, we got that. I reiterate, in science it's more important that there be a means of proving an idea wrong than proving it right. You can't call it science if there's no way to prove it wrong. Doesn't mean it's an invalid thing. Just don't call it science. What's an example? Can anybody think of one? I got one right off the top. It's fresh in my head.
Religion.
Really?
Technically prove religion wrong, so we can't really...
Yeah, at this stage in our lives and technology, yeah. It's, you can't test it and prove that it's wrong, right? Some people, even argue that, but you know what I mean in terms of science. There's no experiment you can do to prove it wrong. Doesn't mean it's wrong, just don't call it science. So that's why we have science and that's why we have religion. Good example.
Economics.
Elaborate.
Well, you can prove that capitalism does work, but you can also prove that communism also works. So neither is wrong, but neither is universally correct.
I'll agree with that. First one that came to my mind was intelligent design. And I'm not saying for or against. You can make your own decisions. Why there was the biggest uproar is because they wanted scientists to offer that as an alternate explanation for what they were doing. And scientists were like, no, because that is not science. We can't prove it wrong. It's not testable. So it doesn't belong in the science class. A lot of scientists might be going too far because they just don't believe it. But it should have been just that. Sure, do it over here, maybe in a different form. Just don't force us to do it in our science classes. That was their issue. Does that make sense? How does technology compare to science? How would you define those two? Applications? Good. I like that. Technology is not science. It's, it's using it, those principles. You'll apply the science to your superhero. Maybe they have some technological weapon. I don't know. How about art? He goes on into art. How do you feel about that?
It's kind of like psychology, where it's really more of a personal thing, emotions and your own reference point, so it can't really be tested.
Personal, emotional thing. Subjective. Yeah, so you're right. It can't be tested, so it's not science. That doesn't mean the two can't overlap. I love having art in science, or using art to help teach science, or use science in art. I think that's awesome. Yeah. Oh yeah, using art. Yeah, you create something. It's ultimately art, but yeah, it's scientifically accurate. And the science it can teach in order to do it. Yeah, we followed all the laws perfectly, and this ended up, and we think it's gorgeous. Yeah. Yeah, I hope, I assume you guys would more so look out into the natural world and see art, or even religion, economics, psychology, and you can start to see some of the science behind it or in it, because they overlap. You can see science in everything if you're looking hard enough. And I'm hoping that after this class you'll have some of the laws and principles and theories under your belt to go, oh, and you can appreciate it on an even deeper level. As long as you don't become that professor on The Simpsons. Remember when they had to have substitutes and the professor, what was he using? He's using that like vacuum bopper toy. You push it back and forth and it pops the balls up. And everything is going off. And can I try? No, not until you can appreciate it on the many levels that I do. Okay, he went a little far. Okay, let's try this out. Clickers. It turned off. So if you have your clickers, pull it out. And let's see if this is going to work. $44. If you don't know how to change your channel, there's a button on the left side that says channel. Push it. Enter 44 and hit the center button in between your arrows. It's like an enter. Okay, there we go. Let's just see here. I'm remembering the wrong button, I guess. That's what I get for using the shortcut. I found a shortcut that went straight to the slideshow. Must have hit the wrong one. Because now I froze it. I won't make excuses. But I was playing with this Monday night and Tuesday. Oh, this is working great. And I can do this and that. It was all smooth. Here we are. All right, let's just undo that. Maybe it's trying to do too many things at once. Having fun yet? Command, return. I was right, it was just something else. Fine, whatever. Okay, it's good enough. So, here's a question. What do you think the answer is? I hit this little button over here. We're playing. Oh, look, a response. Somebody responded. Oh, so look, so other people respond. You can see your number. You also can see on your thingy when it hits, you know, if you say A, you should see an A up there so you know if you got it. If you want to change your answer, you can until I close polling. So you try hitting a few different buttons, I don't know, and then go back to the answer you think it is. I'll move the channel 44 now out of the way because you guys all know that. And then when I get, tired of waiting on you, I can do a little clock and say, okay, you have 30 seconds. Polling will close in 30 seconds. You can change your answer, or decide, in it whenever. I'll just give you plenty of time this time as you're playing around, especially those of you that have never done it before. Has anybody that has a clicker, did it not work?
I'm not even sure where to go. Is it presentation or just?
Presentation. You just hit A, B, C, or D. No, you should just have to push, for example, B. Push it. We'll try, we can do this many times. So there, the polling, the time ran out, so it closed it, and there's the answers. Most of you thought the answer was C. A few of you thought it was D. It's great. We can see what everybody's doing. You all participated instead of the few that just raised their hands, or some that raise their hands and the rest of you don't commit. Now we can all commit. The correct answer was C, by the way. Process. C there. So good for you. Let's try another one. Great advances in science occurred with the invention of, see what you think. We open polling and you guys can answer. Try again. Make sure it's working again. Did you get yours in the back? If you push a letter, does it show up on your screen? You can push a different letter and you ought to see your ID number too show up on the bottom here. Oh, you know what? I just realized. Okay, I got to figure that out. I can see everybody entering down here, but since I'm in the PowerPoint slideshow mode, you can't see it. No wonder. But it displays right in here, so you have your own confirmation. Has everybody responded to this one? I can see too. I should have checked last time. I can see there's been 28 responses. I should have paid attention. I know there's more than that in this class, but I don't know if all of you have your clicker yet. They're working theirs out, so I'll leave it open for a moment. Yeah.
So last night I registered this, and it just took me to the website, just put in a number. But how do you recognize that number is?
So by you registering, what that allows me to do is it associates you and your UID number with that clicker ID number. So I can download a roster from WebCT. Actually, I don't even have to. This Turning Point Technologies, when I save a session, I can export your answers, and it will record the point values if I assign them or whatever, just the fact that you answered, into WebCT, and I can see that. So I'll know who answered what and how and when. So I can tally this throughout the semester, and don't worry, we're not counting yet. If you participated every time I asked something, you'll get 100% of the participation points. If you only answered 50% of the time, you'll get 50% of the participation points.
So is it just a participation period and marking it and see if it was the right answer?
I have no intent at the moment, no. I want you guys to participate and commit. That's my intent. If I do, like, yeah, this one counts, I'll warn you. But I don't anticipate doing that at this point. Say I can tell you guys aren't reading the chapter and you just asking questions that I know the book went over for 5 pages. You know, I might choose to give you a quiz, and this would be an ideal way to do it. But I more want to see what you guys think and how well you're picking this stuff up. Because if I can, I can ask a question again, or I just explained something, I ask a question about it, I think I did great, and 60% of you still get the wrong answer, well then obviously I got more work to do. So, did it work for everybody this time? I see a few more responses. We'll stop. Most of you thought B. That is the correct answer. Who put C? You're just having fun, aren't you? All right, let's see here. All right, let's see if you were paying attention. Answer that one. Polling's open. I'll give you 30 seconds. Well, there were 30 that responded last time and 30 this time, so I'll assume you're done. Anybody not done? Latin, huh? That's fine. It's mathematics. The language of science is mathematics. It's not subjective. It's to the point. We're going to use it. What do you think about this one? Go. Did you answer yet? Few people left. All right, that was everybody. All right. Most of you thought C. So it seems like most of us are getting it. Remember the A, I would say, in my mind, that's more like a hypothesis, a guess, an educated guess based on facts. Things you already know, you base it on that, but you don't know yet. So you're kind of guessing. That's not a theory. A theory is more well-tested hypotheses. We haven't seen it to be wrong yet, so we're going with it. That was C. Get that out of the way. And so good. Most of you are getting it. It's in your book too. Let's see what else we got. Go. Hopefully this one doesn't take you long. And you can already get a clue, especially if you've looked at the chapter and what I just discussed and the terms I went over, what I feel is important. Hint, hint, wink, wink, homework and or test, or when this class is gone 2 years later, I hope you remember these type of things. Almost everybody's responded. There's everybody. Good for you. The correct answer is C. 90% of you thought that. All right, you're getting the idea. You can put your clicker away for the moment. Well, yeah, you can put it away for the moment. We're going to start chapter 2. Do a few demos. So if you haven't got your clicker yet or register it, I hope to ask at least one thing every lecture. It's my intent. So I intend to use them a lot, is my point. I can do it on the fly too. I don't have to have the PowerPoint. I can just, how many of you think it's going to go to the right? A. Left, B, not move at all, C. Right, left, we'll review, and you can just answer. And I can count that as participating if I want you all to commit. So sometimes we'll do it more on the fly. All right, chapter 2 is Newton's first law of motion. And it's all about one concept, and that's inertia. Does anybody already know what inertia is? A few of you think you do. Who's never heard of the term inertia before right now? Oh, that's good. My wife has it because she watched Bill Nye the Science Guy. He said, inertia is a property of matter. So she knows that much. Galileo, it talks about him, and in the previous chapter, he was concerned with how things move rather than why they move, which is a big step and that's typical of scientists. Why they move is more subjective. Philosophy, religion, and science doesn't necessarily always give us the whys, but it can explain how. And it seems to follow these laws, so I can tell you what's going to happen. I don't know why when I do this it works, but it does. I've observed it and tested it. We have theories. Here's an equation to guide your thinking. So Galileo was one of the first to do that. He was a great experimentalist, even though, you know, the story of him dropping 2 balls off the Tower of Pisa, he might not, there's rumors that he might not have actually even done that, which is kind of ironic. But that's all it would have taken. He was great. So if somebody can talk until they're blue in the face about theories and things, well, you know, sometimes the easiest way to end the argument is, well, let's just find out. Oh, it does this. Well, you're wrong. Sorry. And so I hope you start thinking more like that. It can save you a lot of time. He started rolling balls down inclines. He started thinking, let's see here. If I raise this up and I let go of it, you know what happens. It rolls down. But he also observed by doing measurements that it starts moving slowly at first, and then it picks up speed, and it's going faster down here. It accelerates. We'll get into these terms more in chapter 2 to make sure you know what they mean. But you've heard them before. Speed, changing position, accelerates down. Well, okay, that increases its speed. What if we go that way? You can see it slows down, stops, turns around, and accelerates back. So when it goes up, it's decreasing its motion. I probably couldn't do that again if I tried. And this way increases. So he was reasoning. Thought experiments are great. You know, he's making hypotheses in his head. If I just push it and it's level, it won't increase. It won't decrease. So it should never stop. It just keeps going. Still keeps going. That's how he got onto inertia. It just, even if you're going slowly, it still keeps going. Most people didn't realize this because we eventually see things stop. You guys already know why. Friction. There's some force, friction's a force, slowing it down, acting on it. Well, if you get rid of all those forces, if you could get rid of friction, take it out into space. It doesn't increase, it doesn't decrease. It continues its motion. And I push it here to get it going. What keeps it going? The property of it to keep going. See, this is good. That's good. That's what we call inertia. It's a property of matter. It's its tendency not to change its motion. Newton's first law of motion is things at rest tend to stay at rest. We'll cover this again next lecture. Things in motion tend to stay in motion. Unless they're acted upon by something. You hit it with a force or something. But if there's no force acting on it, it won't change its motion. If there were no friction, it'd keep going forever. You know, if you throw this out in space, whoosh, it just keeps going at a constant speed without increasing, accelerating, or decreasing. It doesn't stop. It just keeps going. It doesn't turn until something acts upon it. That's the gist of Newton's first law of motion. And that's the property of matter, that inertia, is a tendency of, or sluggishness, laziness, the words I like to think of it. Things don't want to change. That's what inertia is kind of. It kind of can measure that. Your book says sluggishness or apparent resistance of an object to change its state of motion. Good, that's what I just said. As you hopefully get into read chapter 1, it is very important for you to know that inertia is not a force. Inertia is not keeping the ball going. Nothing's keeping the ball going. It's going because it has inertia, that property, because nothing has acted on it to change it. Does that make sense? It's kind of, you go to jump over a river, you know, whee! You act on the ground to push off. But while you're in the air, nothing's propelling you forward, but you're still moving forward, right? That's inertia. It's not causing you to go forward. It's just your tendency to keep that motion going. It doesn't need a force to keep you. Is that making sense? Because inertia can be kind of confusing. Yes. Yeah. Yeah, that'll stay there forever until something acts on it. Or if it's already moving, you have to act on it to change that motion. Speed it up, slow it down, stop it, turn it. Yeah. Is there a difference between inertia and momentum? Yes, we'll get to momentum later. Momentum is kind of inertia in motion, if you will. And so not only does its inertia contribute to momentum, it's actually its mass, but how fast it's already going. And I don't mind because it comes later, but you guys can comprehend this. We'll just revisit it. Would you rather get hit by a Mack diesel truck going 5 miles an hour or little Timmy on a tricycle going the speed of light? The truck, I hope, it's got a lot of mass, but it's going slow. Where Timmy has little mass, but he's going big. That's momentum. When you think of that, you know, how hard is it going to be to stop it? It'll take force to change motion, and momentum is involved with that. So momentum and inertia are different. Inertia is just this property that wants to resist a change in motion.
At what point is it moving because the force is exerted on it?
All right. This is at rest, correct? At least in our reference frame. This is at rest. So it doesn't want to change its motion because of its inertia. So if I want to change its motion, I have to act on it. That, when I kicked it, that acted on it and got it moving. Now it keeps moving until something else acts on it, which in this case was friction. But if I did that out in space or there was no friction, that would have just kept sliding forever until it hit the wall, because that acted on it. Let me end with this demo. Oh yeah, it only takes a minute. You think it'll work? Drum roll, please. Inertia. All right, have a good day.